Are you a fan of big ideas and stimulating debate? Then we've got the perfect event for you, How the Light Gets In, the world's largest ideas, science and music festival. Returning to Kenwood House in London this 21st to 22nd of September, the festival is a hub for world-leading thinkers, scientists, politicians and artists. With this year's festival theme Navigating the Unknown, expect to see Roger Penrose, Sam Harris, Sabina Hossenfelder, Joshua Bengio and more over a packed weekend. With our very own culture editor Alison Flood hosting an event on whether space exploration is the answer to humanity's problems, this is one not to miss. And you can get a 20% discount on festival tickets. Head over to howthelightgetsin.org and enter the promo code NSL24 for your discount, and we hope to see you there.
Hello and welcome to New Scientist Weekly, your one-stop shop for the most fascinating science and technology news. I'm Christy Taylor in New York.
And I'm Rowan Hooper in London.
This week on the podcast, we are going to talk all about the tools we already have for solving the opioid crisis in the US, a mysterious case of ocean cooling, and finally, an explanation for the famous WOW signal from space. Is it aliens? You'll have to listen to find out.
Plus, how AI may help us deal with a shortage of programmers for one of the world's oldest coding languages. But we're going to start with a story that actually gives me the willies, and it's got really big implications. So, you know, Christy, how some people who are in a coma, they're actually somehow aware of their surroundings. It's a spooky thing to think about. And we thought it was about 1 in 10 people who have this thing. But new research now suggests it could be as many as 1 in 5 people.
Whoa. So 1 in 5 people in comas are aware of what's happening around them. I mean, that kind of feels like we'd have to change the plots of quite a few movies or TV shows if this is the case. And maybe more importantly, reconsider how we understand what a coma even is.
Yeah, that's what it seems, and that's what we want to talk about today. Alexandra Thompson's here to tell us about it. Alex, what is going on? Because it seems like being in a coma isn't this sort of deep nothingness that we once thought.
Well, for most people it probably still is, but there's always been a few people who are unresponsive, so they can't move or speak, but they're aware of their surroundings.
Right, so that's locked-in syndrome, right?
Yeah, that's correct. So now some US researchers wondered if there were more people than the 1 in 10 you mentioned who we thought. So they decided to carry out behavioural and brain imaging tests on 353 people with severe brain damage while they were asked to think about a range of activities.
Right, so this is when people are asked to imagine they're playing tennis or walking through their house, for example.
Yeah, so both of those, and also swimming and as if they were making to clench their fists. So they had to think about this for 15 to 30 seconds before pausing and then thinking about it again, and that was repeated 7 times over 5 minutes. And it's probably harder than it sounds to imagine swimming on and off for that long.
Yeah, I'm struggling to perceive it myself. What did they find?
So among the 353 people with brain damage, 241 showed no outward responses to these instructions. So they didn't react, they didn't manage to actually clench their fist, for example. But of those, 25% showed brain activity that matched that of volunteers without brain damage who were able to clench their fist. And for people in a coma or vegetative state specifically, it was 20%.
In other words, people's brains showed activity associated with thinking of playing tennis or clenching their fist or whatever, even though physically they were unresponsive. So, I mean, that would indicate they're hearing the instructions and following them while seeming inert. I mean, I can immediately see that the issues here for end-of-life care and decisions might become even more complicated and require even more careful consideration with people's autonomy, human rights.
Yeah, and it could be very widespread. So estimates suggest up to 400,000 people worldwide have a prolonged disorder of consciousness. So that's, a coma or a vegetative state. So could thousands and thousands of them have this hidden awareness? And when it comes to making these really difficult end-of-life decisions, perhaps more of these people are wishing to be kept alive than we realise.
Yeah, I totally think that's the case. I've actually interviewed people who've got locked-in syndrome by talking with them through a computer interface, and it was a really quite a humbling thing to do, actually. And what I learned was we project onto them what we would feel if we were locked in. And that's what William James called the psychologist's fallacy, the confusion of your point of view with that of the other person or the patient. So in this case, we might think, if you're locked in, we might think, oh, life, it couldn't be worth living in that state. But that's not the case if you actually ask people with locked-in syndrome how they feel.
Yeah, what is the case? How do they feel?
Yeah, well, many people had never been asked this question in Locked In because everyone assumed that they had a terrible time. When they were asked, they actually were remarkably happy. And one woman I met said she'd gained a greater understanding of herself and the world. Now she was locked in, and she said she was happier now since she had this stroke that left her locked in than she was before.
That's incredible to hear. And I guess one of the questions I have, though, is like, what if they're completely locked in? They can't use an eye detector, computer interface. Could we still communicate with them? Could we still detect, their awareness with this like fist clenching test, for example?
Yeah, possibly with brain-computer interfaces, which is the sort of thing that certain people are researching at the moment, naming no names. So studies suggest it can take just half an hour to train one of these to transform brain activity into attempted speech that you see on a screen. So, I see there being no harm in doing the research to put it all to the test because it could really be transformative.
Now, earlier this month, the US Food and Drug Administration approved another medication for reversing opioid overdoses. And this really fried my head, actually. The drug's maker is Purdue Pharma, and that's the same pharmaceutical company that helped fuel the whole opioid crisis in the 2000s. And if you've seen Dope Sick, you'll know the story. And so this new drug joins 5 others already approved for reversing overdoses. And what we want to talk about now is what dent do we think that can make in a crisis that killed more than 80,000 people in the US last year alone. Grace Wade is here to tell us more. Hi, Grace.
Hi. Thanks for having me.
Tell us about this medication. How does it work? Is it any different than the others already out there? There's one called naloxone. Naloxone, that's the one people might have heard of, for example.
Yeah, so this medication called Zurnai is an automatic injection, think like an EpiPen, of the drug nalmefene, which rapidly blocks the effects of opioids to reverse overdose. It is the 6th medication that has been approved for reversing opioid overdoses, but unlike its counterparts, it has a stronger and longer duration, meaning it will be more effective against an increasingly toxic drug supply. Almost all of the opioid overdoses in the U.S. are now due to fentanyl, which is much more powerful than heroin or prescription opioids.
So it makes sense that when you've got these more powerful drugs, you need more powerful tools to save lives. All right, so we've got Zurnai. Does it mean can we expect that might have a significant impact on reducing deaths from overdose?
I think it's too early to know for sure what sort of impact this medication will have on overdose deaths. But I think it is quite clear that it will do little to actually stem the opioid epidemic, which has been accelerating for more than 2 decades now. And that's because so long as people continue using opioids, they continue to have a high risk of overdose.
Right. So this is just sort of the back end of saving lives when the crisis continues. So what would it take then to make a dent in the actual crisis itself? As you say, it's been killing so many people for years and years. What haven't we figured out yet?
Yeah, well, to really stop opioid overdoses and deaths, we have to treat the root cause of the problem, which is addiction. And the good news is we do have the tools to do it. Medications for opioid use disorders, such as buprenorphine and methadone, are the most effective treatment for opioid dependence. They work by fully or partially binding to opioid receptors in the brain without producing a high. That means they can still ease cravings and withdrawal symptoms. And research shows that people taking these drugs have an almost 60% lower risk of overdose. They're also less likely to use opioids like morphine or heroin and more likely to stay in treatment than those who aren't given these medications.
That sounds like amazing news.
It is. But the issue is that 75% of people with an opioid use disorder in the U.S. aren't receiving these medications, and healthcare providers rarely offer them. So, for instance, a study published in June found that 2/3 of outpatient mental health facilities across 20 U.S. states do not offer these medications.
Yeah, that's really upsetting, isn't it? You'd think that the medications would be more widely available, given we've got this horrendous crisis. So why aren't they?
It really comes down to 2 issues: stigma and regulatory barriers. A recent analysis of more than 66,000 doctors found that the most common reason they don't prescribe medications for opioid use disorder is essentially bureaucratic red tape. But the US government is now putting regulations in place that will hopefully remove some of the misconceptions about these medications and finally get them in the hands of the people who need them, ideally before they need any of these overdose reversal medications.
Let's take a quick break to tell you about some of the great interviews in our Culture Lab feed. Next week, psychologist Lucy Fawkes gives us an insight into the teenage mind and looks at the intricacies of social groupings, bullying and risk-taking, plus advice on what parents can do and when to let their teenagers sort through difficulties on their own. That's coming up on Tuesday.
And if you're looking for some entertainment, TV columnist Bethan Ackerley has a roundup of the year's best science fiction and otherwise science-y television so far. We've got Time Bandits, Supercell, and the best documentaries of the season, plus a preview of the good stuff yet to come, by which I mean Severance Season 2, coming in January, not soon enough. That's already in your feed.
And now we're going to turn to one of the most cherished items in the search for extraterrestrial life. That's SETI, and something known to alien hunters as the WOW signal. So this was a signal first spotted in the 1970s, and the SETI lot really cling to this as the best evidence they've ever had of aliens. It has been difficult to explain, but now we might have an explanation for it. Alex Wilkins is here. Alex, give us a refresher first on the WOW signal.
Yeah, so I'm going to take you back to 1977 at the Big Ear Radio Telescope at Ohio State University. It's this vast 200-plus meter radio dish. You might have seen similar radio dishes like Arecibo, or there's this huge one in China, and it detected this short, sharp burst of radio waves with a really strange, narrow range of frequencies, and this was similar to atomic hydrogen's natural emission frequency. When astronomers saw this at the time, they didn't know any astronomical processes that might produce such an emission, and the astronomer on duty, this guy called Jerry Amon, scrawled down the phrase "wow" in red pen on a printout of the signal. And that phrase has now become kind of synonymous with the signal. It's now called the WOW signal, and it's defied explanation in the decades.
It's a good job he didn't write a swear word. What the?
Yeah, I was going to say, I was expecting WOW to be an acronym, and it's just the word.
It would have made the segment much more interesting. Yeah. And it's defied explanation in the decades since its observation, and people have, as you mentioned earlier, clung to it as evidence of an advanced alien civilization, if there isn't a more compelling explanation. But scientists have obviously tried to explain it with less exotic theories like fast-moving comets releasing clouds of hydrogen gas, but no explanation so far has really explained it. There's always been small problems like there not being enough power to match the signal that they observed.
Yeah, so the director of the Big Ear Observatory wrote to Carl Sagan and said, "The WOW signal is highly suggestive of extraterrestrial intelligent origin, but little more can be said until it returns for study." But the problem is it never returned for study, right? So how can we say more about it?
So yeah, you're right that whatever caused it hasn't come back, but there are similar telescopes that we can turn to. So there's this group of astronomers at Arecibo, which is this really vast radio telescope in Puerto Rico. And
Rest in peace.
Yeah, you might have seen it collapse in 2020, and there were these really dramatic images at the time, and astronomers are very sad when it did collapse. But the astronomers there realized that their experimental setup was really similar to the original Big Ear telescope setup. So they repurposed a set of data that they'd originally been collecting of red dwarf stars, which they were hoping to find potentially habitable exoplanets around, and they began to comb through it and see if they could find any candidates that might look similar to the WOW signal. And surprisingly, they found quite a few. They were all from stars that were passing in front of clouds of atomic hydrogen that matched the frequency range of the original signal really well, although with much lower power.
Right, and it seems like that lower signal strength is really key to what has been so puzzling about this before. So how do they explain it?
Yeah, so it's really proved the trickiest part of the whole kind of mystery. So the astronomers think that if instead of a star behind the hydrogen clouds, there was a super bright object behind it, like a highly magnetic neutron star, which they call a magnetar, and the star gave off a flare and then caused all the hydrogen atoms to be excited at the same time and begin emitting a beam of coherent light, which is effectively a laser in space. But because it's microwaves, they call it a maser. If that happened, then it would easily produce the power levels needed to produce the WOW signal.
That's definitely a lot less exciting than aliens, but it still seems pretty cool to me. And I guess what I'm wondering is whether we know for sure this effect could definitely exist.
So that's the big question mark over all of this. We've seen masers in space from clouds of molecular hydrogen, though admittedly not many, but we've never seen a maser from a cloud of atomic hydrogen. And magnetar flares are pretty rare anyway, but to have one lined up perfectly behind an atomic hydrogen cloud in just the right way to make it emit a maser would be even rarer. So if this was what caused the wow signal, then in some ways for astronomers it's just as exciting than aliens. But I'm sure lots of people who aren't astronomers would disagree that it's as exciting.
Yeah, come on. Astronomers are perhaps fibbing if they say that's more exciting than aliens. Is there any way we can check for sure?
So the astronomers that I spoke to said that you could go back to the original patch of the sky that Big Ear was looking at, and you could try and look for these hydrogen clouds or even a magnetar. But the problem is, unless magnetars are actively flaring, they're really hard to spot. So if the wow signal was caused by a rare magnetar flare, then we'd have to be really lucky to spot it again.
I mean, wouldn't you want to look in that same area anyway in case it was an alien sending signal?
Yeah, I think we should go back. If it was up to me, we would.
Okay. What about the SETI community? What do they think about it?
So a lot of people in the SETI community, although it's clung to as potential evidence of aliens, a lot of people were quite skeptical about the signal in the first place, and they thought that at some point it would be explained away by maybe a technical glitch or some kind of mundane astrophysical explanation. As for this new idea, I think people are also a bit skeptical given that we've never seen an atomic hydrogen maser before. One astronomer I spoke to said that it seems like a bit of an overcomplication. A magnetar can produce short radio emissions of the kind seen in the wow signal. So he kind of said, why do we need this complicated maser thing on top of it?
Great. So the wow signal industry rumbles on.
Yeah, it's self-perpetuating.
Great. Okay, thanks, Alex.
And next up, this week Matthew Sparks reported on how lots of huge organizations like banks, airlines, and government departments are still reliant on ancient computer code dating back to the 1960s. It's called Cobalt, and Cobalt code was designed and written for large mainframe computers, the kind that we mostly abandoned in favor of smaller servers and cloud services. Which also means that universities mostly no longer teach the Cobalt language, making it a lot harder to find people who know how to solve problems when they come up.
Yeah, so and this is something that maybe AI can help with. But look, first to explain why we're in this position. So as you say, like we had these massive old mainframe computers and they've all gone. But really weirdly to me, some of the code that was written for them, that never got replaced. That's just still there on modern machines, just trotting away, doing its thing. And when we need to modify that code or replace it, we don't have people anymore who know how to do it, you know. And Cobalt dates back to 1959, which is basically, you know, as old as electronic computers. And that's why AI is being touted as potentially a solution to this.
Yeah, so when you say we don't have enough skilled people, I mean, presumably that's because no one's learning, you know, no new people are learning how to write Cobalt anymore. And kind of the original skilled people are retiring or even dying off, right? I mean, you said as old as computers themselves.
Yeah, and this is what I love about this part of the story, right? So do you remember there's an old Clint Eastwood film called Space Cowboys. It's about astronauts who were dragged out of retirement to work on an old Soviet satellite. And so with analogy to that, there's a company called Cobalt Cowboys, and it does the similar thing, like in real life. These are mainframe engineers from the olden days, old timers, who are called back into work. Some of the contractors are in their 70s, and they're called on to work on Cobalt because they're the only ones left who understand this thing. But obviously, you know, as you say, it's not sustainable.
Yeah, I imagine if I was in my 70s, I wouldn't necessarily cheerfully embrace the idea of continuing to save people's butts until I die. So going back to AI, I mean, how is this the solution? I do sometimes find myself wondering if there's anything that AI isn't being considered the solution for at this point.
Yeah, exactly. So what they're doing, there's a few companies that are teaching AI models specifically how to code in Cobalt. And they say that they don't want to replace humans, but they're going to help human engineers to understand the code. And it's like an ancient text at this point. You know, it's undocumented, it's impenetrable for humans, so that these new engineers can then write replacements.
Got it. So, you know, if we're talking about this as a proposed solution, how well could it actually work? You know, how effective can a modern AI be at getting to grips with an ancient cuneiform-like language.
No, it is like that. It's like humans studying our ancient ancestors. But yeah, Matt says that these Cobalt-trained models can understand Cobalt code pretty well. So it does seem like that the AI could play a role in getting us out of this obsolescence trap that we've got ourselves into.
I do support the idea of these coders themselves being able to actually retire. So that sounds amazing. All right, next up, an update from the oceans, where we're seeing a cooling in part of the Atlantic Ocean that scientists don't actually know how to explain. And it could land us in very interesting climate territory as the globe overall shifts from the warmer El Nino to a cooler La Nina.
But Christy, aren't we still talking about the oceans being like weirdly hot? Because, we hear about bathtub temperatures in some places, right, even?
Right, we definitely are. And if you look at most of the Atlantic, it is still extremely warm compared to what would be expected for mid-August, which, of course, continues to raise concerns for the hurricane season. And as we've discussed before, ocean temperatures on average were breaking records for 15 months straight, starting in April of last year. But as climate reporter James Deneen reported earlier this week, we are also starting to see signs of a transition to cooler temperatures, mostly in the regions of the Atlantic where that tends to happen first, which is at the equator. So if you were to look at a sea surface temperature map of the Atlantic, there'd be a lot of red all over, indicating, again, warmer than usual temperatures. But then there's this kind of refreshing blob of blue and white at the equator, which indicates more normal or even cooler than usual temperatures.
Right, so that might indicate, as you say, the transition to La Nina. So why is it such a mystery then? Isn't that what always happens? You get this recurring oscillation between warm and cool states.
Yeah, that is how things are supposed to go, mostly thanks to these wind patterns at the equator. The winds are either pretty powerful in the La Nina phase, which allows for colder water deeper in the ocean to move upward and, help keep the surface cooler, or they die down and stagnate, and all that cooler water stays deep down, which is why El Nino primes us for warmer ocean temperatures. And then there's this period between the two where conditions are kind of neutral. So overall, as you said, we see a cycle that can be anywhere from 2 to 7 years long. And we've already discussed how the Pacific Ocean began this sort of expected cooling in May. It's in that neutral space right now where it's no longer officially El Nino, and it's forecasted to hit the threshold for a La Nina in the next month or so. So nothing strange there. But on the Atlantic side, we've also seen cooling for the last 3 months. And the thing is, Rowan, as James reported, the Atlantic has been cooling without help from stronger equatorial winds. We have records for Atlantic cooling going back to 1982, and it's actually cooled faster than any time in that sort of span of records.
Okay, so massive puzzle for scientists. Do they know what the hell's going on?
Nope, not yet.
Great. Great. Well, that's a big mystery. But look, I mean, I can only imagine that if the El Nino has had this really strong impact on the climate in the last year, it's going to make a big difference that the Atlantic has cooled so fast and is doing it simultaneously with the Pacific.
Yeah, that is absolutely something researchers will be watching. The Pacific Ocean's influence on climate is much bigger. And with a Pacific La Nina, we do tend to see dry weather in the western U.S. and wet weather in East Africa. But Atlantic Ninas do play a role, too. They tend to reduce precipitation in Africa's Sahel region and boost it in parts of Brazil. But also these patterns could have opposite effects on things like hurricane formation in the Atlantic. The Pacific Nina is expected to increase the likelihood of hurricanes whenever it does arrive, but an Atlantic La Nina may reduce some of the conditions required for hurricane formation. So there's a whole additional knot there. Plus, the Atlantic Nina may actually delay the development of the Pacific La Nina, which would slow down all the cooling that we've been looking forward to since this whole cycle began last year.
So basically, there's a massive knot that atmospheric scientists are going to have to try and unpick, and I do not envy them that job.
No, me neither. We will have to wait and see what happens still, though. Both oceans are still technically in the neutral orientation. They're neither El Nino nor La Nina. So some of this will depend on when we see which ocean, Pacific or Atlantic, kind of cross over into that official La Nina state. That's it for this week. If you like this show and think more people should know about us, please do give us a 5-star rating or even a review on Spotify and Apple Podcasts.
We got more fascinating stories from New Scientist on our website at newscientist.com. And we'll be back next week. Bye for now.
Bye.
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.